In this video, I'm going to explain about Floyd's algorithm. In the previous video, we have discussed about Warshall algorithm. In that Warshall algorithm, we find out for the given graph, we find out the path matrix. That means the transitive closure. That means which are the paths available from which vertex to other vertices. Okay, that path we find. That means what are the or which are the paths are available between the all the nodes of the graph that we find out in the Warshall algorithm. So now this Floyd algorithm is used to obtain the distance matrix. See, in the Warshall algorithm, we find the path. Now, in that path, now we have to find what is the shortest distance or what is the shortest path. Okay, so this Floyd algorithm is used to obtain what? Shortest distance between every pair of vertices. So hence, we'll say this Floyd algorithm used to obtain the distance matrix. That means it is used to find the what? Shortest distance. Shortest distance between what and what? Between every pair of vertices. Between every pair of vertices, we need to find the shortest path. So that means, so this Floyd algorithm is used to address all pair shortest path problem. Okay, so that means for the given graph, we need to find what? The shortest path. Okay, between all the pairs. So hence this problem is called all pair shortest path problem. So for this problem, we are using Floyd algorithm to find the shortest distance. Assume, okay, now let us understand this simple concept through simple example. Let us consider this directed and weighted graph. For this graph, we need to find the distance matrix. That means what is the shortest path from one vertex to all other vertices from between every pair of vertices. Okay, so that means what is the shortest distance from A to B, A to C, A to D, similarly B to A, B to C, B to D, similarly C to A, C to B, C to D, D to A, D to B, D to C, like that. Between every pair of vertices, we need to find what is the shortest distance. Again, for that, so whatever the formula we have used for that, what formula means, what the concept we use in the Warshall algorithm, we need to compare always the column value with the row value. The same concept here also we are using. So always we need to compare what? Column value with the row value only. Okay, this we have to use. If you change this order, you will end up in the wrong answer. So again, remember for both Warshall and as well as Floyd algorithm, we need to compare what? Column value with the row value only we need to compare. Now in the Warshall algorithm, what we did, in the Warshall algorithm, so we have written adjacency matrix for the given graph. Adjacency matrix, because there is no cost involved in the edges, so this is not weighted, so only the we written whether edges there or not, that written in the adjacency matrix. But now since in the graph, now in this graph we are having what? Weight. So now we need to write the cost adjacency matrix. They will call simply adjacency matrix. Here we need to write what? Adjacency matrix. Okay, cost adjacency matrix. So that cost adjacency matrix, see what I'll write. So again, how many vertices are there here? 4. So that many number of row and that many number of columns we need to write. So now again, what is the distance? A to A I'm writing 0. So what about A to B? A to B, any edge is there directly? No, there is no direct edge between A to B. There we are writing 0. But so yes, since A to B there is no edge, but it is not, doesn't mean that it is not possible to reach from A to B. No, still we can reach A to B, even though there is no direct edge from A to B. I can reach from A to C and then C to B. So, but that path we don't know. So here we are in adjacency at the direct connections. So A is not going to be directly, so I am writing infinity. Okay. So now A to C. What is the entry in A to C? A to C is 3. A to D is no edge, so I'm writing infinity. Similarly, now from B to A, it is 2, so B to B is 0. B to C. B to C edges there are no, so I'm writing infinity. B to D edges there, no, again infinity. C to A edges there, yes, C to A edges, no edge, so I'm writing infinity. C to B edges there, yes, that cost is what? C to B is 7. C to C is 0. C to D edges there, yes, direct edges there, that is 1 cost. D to A edges there, no, is D to A edges there, that cost is 6. D to B edges there, no, so infinity. D to C edges there, no, infinity. D to D edges there, 0. So this is our cost adjacency matrix for this given graph. So in Warshall algorithm, what we did actually in the Warshall algorithm, whatever the adjacency matrix for the given graph, that adjacency matrix A only we have considered as what? R to the power of 0. That means what? So there we use the transitive closure, there is path matrix, the R. But here what we need to find out? Here we need to find in the Floyd algorithm, we need to find what? Distance matrix. Now the same thing now we'll call as a D to the power of 0. So that means again, so this is the distance matrix by considering 0 intermediate nodes. That means here we are not consider any intermediate nodes. These are direct connections. Okay, that. So D to the power of 0. Now again we need to construct what? D to the power of 1. By using this D to the power of 0, we need to consider. So now we'll consider using any one vertex as an intermediate node. So now I'm taking one vertex, okay, that one vertex row and the same vertex I'm selecting. Okay, so now I selected one. That means now I need to check. So through A I can reach what and all the nodes I can reach. Okay, that I'm finding. So for that I consider the A row and A column. Now again, this you should keep it in mind. Again here we are comparing what? Column value with the row value only. Here what is the column value? Column value among 2 and 6. These are the two column values. Here 1 and here 1. So 2 and 6. Row value only 3. So first I am comparing this column value with this row value. Okay, 2 and 3. Now always while writing, what was always writing the column value first, because column value first I am comparing. Here column value is what? 2. This 2 is nothing but B comma A. So B comma A is equal to 2. And what? This I am comparing with what? This row value. This row value 3 is what? A comma C. So A comma C is equal to 3. So if I get A get cancelled. So I will say now B comma A. That means now I'm finding the shortest distance from B to, A cancelled, B to C. B to C. B to A get cancelled, B to C. Now I'm finding the shortest path from B to C. But actually see here, if you see, observe the graph, there is no direct edge from B to C. But still we can reach B to C through what? A. That's what we are doing now. That's what the A get common. So B to C I'm finding. So the B to C what? Now what I have to find, suppose for example, what happens some case, suppose some, okay, in this, okay, that is B, then this is A, this is C. Now assume there is a direct edge. Assume there is a direct edge. So this direct edge value is, say, let us take 8. Okay, let us take, this is 3, this is 2. For example, this is another example. Now in this case, reaching from B to C through direct edge is 8, but through A is 3 plus 2, 5. So that means we can reach B to C through this path at the shortest distance when compared to the direct edge. So whenever we are finding the shortest distance between any two vertex, we need to find out whether reaching from one vertex to another vertex through direct edge is minimum or through the path is minimum. So here also, now and again you have to say. So again, in order to find B to C shortest path, so suppose if there is a direct edge passing through the edge or passing through the path, which is minimum, that I need to find out. For that, what I will do, so now I'll write B comma C is equal to minimum of direct edge, that is BC, comma now to the path, that is what? B to A plus A to C. So now substitute the values. This is minimum of what? B to C. You check B to C in the previous, because now I am constructing D to the power of 1 by using D to the power of 0. So B to C is what? Infinity, comma B to A is 2. 2 plus 3. So it is 5. Which is minimum? 5 is minimum. So I got new value BC is equal to 5. I got. Okay. Now similarly, now what I have to do? Now similarly, I need to calculate. So again, I have to compare what? This column value I need to compare with this row value. Now same thing again. This column value is what? D comma A. D comma A is equal to 6, and this row value is what? A comma C. A comma C is equal to what? 3. A get cancelled, so the DC. So DC is equal to minimum of what? So minimum, whether direct edge is minimum or the path DA plus AC. Okay, this is edge, this is path. So this is nothing but minimum of DC is what? In the previous D2C is what? Again, in D2C is infinity. D to A is 6 plus 3, 9. So which is minimum? 9. So D to C is 9. I got two new values. Okay. So the two new values, now I'm going to write the first. Okay. So A, B, C, D. So always set the first the new values. New value what I got? BC. Earlier B to C is what? Infinity. Now I got B to C is what? 5. And earlier D to C is what? Infinity. Now I got D to C is what? 9. So that I written first because these are the two values, new values I got. Now remaining values I am writing as it is, copying from the previous one. That is 0, infinity, 3, infinity, 2, 0, infinity. So then infinity 7, 0, 1. This is 6, infinity 0. Now this is my D to the power of 1. That means this is the distance matrix I got by considering one vertex as an intermediate node. That is what the A. That is through A. See, through A, from B to C I can reach through A, and similarly I can reach what? D to C. D to C I can reach through A. D to C 6 plus 3 9. Okay, this is what we found out here. Okay, now next we need to construct D to the power of 2 by using D to the power of 1. So for that now I am considering, so B row and B column. So B column I marked. Now I'm marking B row. Now again the same concept. What is that? So we need to compare what? Column value with row value. So column value is only a 7. So this 7 I'm comparing with this first 2. Okay. So this is what? Now column value is 7. So that is nothing but what? C comma B. C comma B is equal to 7. And this row value is what? B comma A. B comma A is equal to 2. So BB get cancelled. So CA is equal to minimum of CA comma the path CB plus BA. So this is nothing but minimum of CA is what? C to A is infinity. Infinity. CB is 7 plus 2, 9. So 9 is minimum. So CA I got 9. So similarly now what I have to calculate? I need to calculate one more thing. What is that? So now this column value I need to compare with this row value now. So that is now again C, this column value is what? C to B is equal to 7, and this row value is B to C. B to C is what? 5. Now BB get cancelled. C comma C. See, always you should take the common inner. Don't cancel the extreme. Okay, in external, only the internal. So C comma C is equal to what? Minimum of CC comma this path CB plus BC. So but previously C to C is what? Previous this one. So previously C to C is what? 0. So minimum of 0. C to B is what? 7. B to C is what? 5. So 12. So CC is equal to what? 0, 12, which is minimum 0. So CC is equal to 0. So I got this. Actually the 0 is, we know that from the vertex to same vertex 0. Now I got one new value, that is C to A, that is 9 I got. Now updating this one. So now what I got? So now, see, now I got the new value. First I done the new value C comma A is equal to 9, and remaining values I copied from the previous D to the power of 1 only I copied. Now this is the distance matrix by considering two nodes as an intermediate node. That is what first I considered through A, and now I consider as through B. So that means I can use two nodes as an intermediate nodes. So this is the distance matrix what I got by considering two intermediate nodes. Now we need to consider the third one. That is now I am marking the C row and as well as C column. Now I need to do the same thing again. We need to compare row value with the column value with the row value. We need to compare. So that means first I'll compare this 3 with what? This 9. Okay. So those this 3. Column value is 3. That is what? A to C. A comma C is equal to what? A to C. Okay, A to C is equal to 3, and what? This row value is what? 9. That is C to A. C to A is what? 9. So C common, so A comma A, but we know that from same vertex to vertex always 0 only, there is minimum, so directly I am writing A to A. So next I am comparing the same column value with this row value. So for that, so the again A comma, this is column value, this is A comma C is equal to 3, and this row value C comma B, that is 7. So C get cancelled, so A comma B. So A comma B is equal to what? Minimum of AB comma this path AC plus CB. So this is nothing but minimum of what? AB is what? In the previously A to B is infinity. Infinity A to C 3 and 7. 3 plus 7, so 10. So I got new value AB is equal to 10. New value I got. So now again one more row value is there. So this column value now I need to compare with what? This row value. So now I need to compare what? This one. This column value, that is again AC is equal to 3, and this was the row value. This is the row value C comma D is equal to 1. CC get cancelled. So now AD is equal to what? Minimum of direct is what? AD. Path is what? AC plus CD. This is nothing but minimum of A to D is what? A to D is 3. A to D is what? A to D is infinity. Infinity AC is 3 plus 1, 4. So I got new value AD is equal to 4. That means I can reach C through A. A to D I can reach through like this 4. So now I got new 3 values. But again, still it is not get completed. Still we are see 2 more column values we are having, 5 and 9. So now again I need to compare 5 with all these 3, 9 with all these 3. Okay. So now if you observe, now again you see here, so now again what I will do, so now I will compare what? This column value with this row value 5 with the 9. So here this is the column value 5, this is what? B to C. B to C is equal to what? See, B to C is 5, and that is I'm comparing with what? Row value 9. So that is what? C to A. So C to A is equal to 9. CC get cancelled. So I got what? B to A. B to A is equal to what? Minimum of what? The edge. So edge is what? BA, comma, path is what? BC plus CA. So this is nothing but minimum of BA. BA is what? Is the previously B to A. You see B to A is 2. So I'm getting 2, comma, 5 plus 9. So which is comma minimum 2. So I got B to C. B to A is 2 only. So similarly I need to what? I need to check the next column value, the same column with value with the next row value. If you observe, now I need to compare what? So this same column value I need to compare with this row value. So now this is what? B to C is equal to 5, and next row value is what? C to B, 7. C to B is equal to 7. So I got CC get cancelled, B comma B, but from the same vertex to vertex, what I will get? We get 0, so I'm writing directly. So next I need to compare what? This one, same column value with this row value. So that is B to C is equal to 5, and this one is what? C to D. C to D is equal to 1. So CC get cancelled. Now B to D is equal to minimum of BD comma BC plus CD. So this is nothing but minimum of B to D is what? Say B to D. B to D is what? Infinity. So this is infinity comma 5 plus 1. That 5 plus 1, that is 6. So 6 is the minimum. I got the new one more value. So now what we did, these two column value compared with all the row values, one more column value is there written. Okay, now I need to compare this one. Now this column value, I need to compare this row value. Okay, so now I need to compare this column value with that particular row value. So now that is nothing but what? Column value, this 9. This 9 is what? D to C. D to C is equal to 9, and this is what? C to A. C to A is equal to 9. So C get cancelled. D to A is equal to minimum of DA comma DC plus CA. What is D to A? See, D to A is 6. So this is nothing but minimum is equal to D to A 6. 6 plus 9, 18. So minimum is 6 only. So I written 6 only. Okay. So next, again, I need to compare what? This column value I compare with this row value. That is again DC is equal to 9, and this 7 is what? C2B. So C2B is equal to 7. So CC get cancelled. So DB is equal to minimum of DB comma this path DC plus CB. So this is nothing but minimum of what is D to B. See, if it's D to B is what? Infinity. So that infinity comma 9 plus 7, 16. So minimum is 16. Okay, minimum is 16. So now last value I need to compare. What is that? The same column value 9 I need to compare with what? This row value 1. So again D to C is equal to 9, and this 1. This 1 is what? C to D. C to D is equal to 1. CC get cancelled. D comma D. Again same vertex 0, 0 only. Okay, now these many values I got. Okay, so how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9 values. See, 9 comparison rate. 3, 3, 6, 9. So each column value I compared with 3 rows. 3 plus 3, 6, 9. Total 9 comparison. So we got total 9 one. Now we need to update what? D to the power of 3 we need to write. Okay, so we need to write what? D to the power of 3. So first I am writing the new values. What are the new values? A to A is 0. That is not the new value. The same value written 0. Then A to B is what? 10. Earlier A to B is what? Infinity. Now I got A to B is 10. Then A to C, the previous value only. A to D I got 4. Earlier I got infinity A to D. Now A to D I got 4. So next B to this one. B to A is 2. This also previous value only. B to A is 2. So then B to B is 0. Then B to D. B to D what I got? 6. B to D I got 6. So then C to A, not C to A, D to A. D to A I got what? 6. Then D to B I got what? 16. Then D to D I got 0. Okay, these are the 9 values. See, 9 values I got. So remaining values I am copying as it is from the previous one. So that is 0, 10 over. This is 3. So then this is 5. Then 0 what? 9701. Same thing I am copying 9701. And this value is 9. So this is what? The D to the power of 3. Okay. See, this is our D to the power of 3. Now we need to consider what? D to the power of 4. Because 4 nodes are there, D to the power of 4. Suppose 5 nodes are there, up to D to the power of 5. So it's a time consuming, but very, very simple. See, D to the power of 4. Now I need to consider the 4th row as intermediate. So I am selecting the Dth row and Dth column. So now I need to compare again same column value with row value. First, see, I am directly will write. So will come writing this column value 4 with this one. Again this 4 with this 16. So then this 4 with 9. Okay. See, I compared for this row column value, the column value with all these 3. So I got these 3 new values. A comma A is equal to 0, direct return. Then A comma B is equal to 10 at the new value. A comma C is equal to 3. These are the new values I got. So next I need to compare what? So next I need to compare this column value with this row value and with this row value and again with this row value. Okay. So 6 I need to compare with these 3. So I will do and see, I compared this column value 6 with all these row values. So I got these are the values. B to A is 2, B to B is 0, then B to C is 6. These are the. Next again I need to do what? Next I need to compare this column value 1 with these 3 row values. So when I compare this one with all these three row values. I got C2A 7, C2B 7 and C2C 0. These are the three values I got. Okay. Thus we compared all column values, all the row values. Now we got the final what? Distance matrix d to the power of 4. Okay, so how many number of nodes are there in our graph? D to the power of that we need to do. Here there are 4 nodes are there, so we did up to d to the power of 4. Okay, so now first I'll write the new values what I got is. Okay, so a to a is 0, then I got a to b 10, then I got a to c 3, then I got B to A I got 2, so B to A I got 2, so then I got B to B 0, then I got B to C is what 6 I got, B to C I got 6, then I got C to A got 7, then C to B is also 7, C to C 0. These are the 9 values again I got. See 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 values I got, 9 values. Remaining values I am copying as it is from the previous one. So that is, here see 4610, 4610. So this is 616, 9. 616, 9. So this is the final distance matrix. So this is the final distance matrix, means from A to A 0, A to B shortest distance is 10, A to C shortest distance is 3, A to D shortest distance 4. Similarly from, that means we find the shortest distance between all the pairs. Hence it is called all pair shortest path problem. So we have found all shortest distance between all the pair. Now we need to write the algorithm for this. Okay. So the name I have given Floyd. The given graph is the input. So first what we are do, so I told for the given graph, what is the first thing what we did for the given graph, whatever the given graph, for that we written the cost adjacency matrix. Okay, that we written, and the same cost adjacency matrix we have considered as what? D to the power of 0. The same thing now I'll do. Okay, so that is now, so same D to cost adjacency matrix, whatever we written cost adjacency matrix C, that we consider as a distance matrix by considering 0 intermediate node. Next what we did, next we did operation on the columns and rows, right? So for that, whenever we are doing any operation on the matrix, we have to use 2 for loops, one for the row and one for the column. So I will use for I is equal to 1 to n number of nodes do. So for j is equal to 1 to n you do. So this for loop, ith for loop is for the row and jth for loop is for the column. So now what we did, each time we have selected what? One vertex. See here, first time I selected the vertex A, then I selected the vertex B, then vertex C, then vertex D we have selected. Okay, so like that we keep selecting. For selecting, I'm using one more for loop. For k is equal to 1 to n. So these 3 lines are same as what we did in the Floyd algorithm also. Okay. So now what we have to do, now what we did while solving the problem, if you observe, so every time we are checking whether edge is minimum or path is minimum of edge comma path. Okay, so that means we always constructed d to the power of 1 by using d to the power of 0. We construct d to the power of 2 by using d to the power of 1. So like that we are constructing one distance matrix by using the previous one. So for that what I will write, so now I will write, so distance matrix, now I am considering d to the power of k of from between I to j I am finding. So this I am finding by what? So by using what? The previous. Okay, so that is what? So that is minimum of what? Direct path. Okay, from which in the previous d to the power of k minus 1 I to j, whether edge is minimum or path, d to the power of k minus 1 of I comma k plus d to the power of k minus 1 k comma j. Okay, so these two, so I'm finding edge is minimum, direct I to j edge is minimum, or from I to k plus k to j, so which is minimum, that I am taken d to the power of k to the power of j. Okay, so that's it. So now end for And for finally, we need to return what? The final distance matrix d to the power of n. So that I need to return. So this is what the Floyd algorithm. So again, analysis, it is very simple. So again, so the problem size is now number of vertices given in the graph, that is the problem size, and basic operation is the only operation what we are doing. We are finding whether edge is minimum or path is minimum. This is the only operation we are doing. So this is the basic operation. So almost for all the graph related problem, there is no best and worst case. We need to find only the average case. So average case we can write as t of n is equal to what? So since I'm using 3 for loops, I'm using 3 summation. I is equal to 1 to n, j is equal to 1 to n, k is equal to 1 to n one time. So again apply formula for this. So outer 2 for loop remains same. So upper limit minus 1 plus 1. So n minus 1 plus 1, n cancel. So this is nothing but I is equal to 1 to n, j is equal to 1 to n. This is n. So if I take this as an outside, so I will get I is equal to 1 to n 1. So again you apply formula for this. So this is nothing but I is equal to 1 to n. So upper limit minus lower limit plus 1. So cancel n. So if this n I will take outside, this become n square. And then I'll get what? I is equal to 1 to n 1. So now apply formula for this one. This is nothing but n square, n minus 1 plus 1. Cancel. So n into n square, n cube. So t of n belongs to big theta of n cube. So this is the time complexity for the Warshall Floyd algorithm. Okay, hope you people understood. If you have any questions, please write it in the comments. Okay, thank you. Thanks for watching.